my right to left, Aaron Anderson and Joseph McFarland, who are in charge of programming the MSP430 as our controller and setting up the CC3100 board for Wi-Fi connectivity. We have Zachary Lindstrom, who is in charge of setting up the server and dealing with all our administrative paperwork, and Luke Szymanski and me, who are in charge of designing the sensing circuit and the battery management circuit. Okay, so as you can see from our block diagram on PowerPoint, the system is set up such that the rope sensor and the sensing circuit detect the water leak. Once the water leak is detected, the alert is sent through the MSP430 and the Wi-Fi to a server. When the server receives the alert, it pulls the identification of the specific sensor and matches it to a table that's stored on the server, and it will then send an email and a text message to alert the user that a leak has been detected. This will help alleviate a lot of property damage, which is caused due to improper early detection of leaks, and so hopefully allow people to save money. We went with the rope sensor for our design purely because it allows for a more universal approach. For example, you can coil the rope sensor around in a spiral to cover more surface area underneath the dryer or a washing machine, or you can even wrap it around a water pipe joint for even sooner detection of the leak. In addition, a very key point of our water sensor is that it detects water and not moisture. It needs to be able to operate in very high humidities without tripping, so you can use it underneath a dryer, washer, or even like a water heater where the humidity can get very high. The battery management system is set up so that we can keep tabs on the voltage of our battery so that we can alert the user before the battery dies, so there's no gap in the actual protection of from the sensing the water. And then the MSP430 is used as our controlling circuit. It's used to control the voltages on our switches for our 2 single-pole double throws, and it also is used to actually read the voltage off our diode and our caps in our sensing circuit and battery management circuit, respectively. Going to our actual testing, we prototyped it on a breadboard. We managed to reliably detect 1.5 milliliters of water, which is sensitive, which is a very sensitive sensing capabilities. Our future outlook on our project is now we're going to work the design and attempt to put it into a compact PCB to make it and put it in a more protectable housing, so we can actually test the circuit in situations where the circuit will be protected from the water and the sensor will just be able to sense the water. So now I will open the floor to questions.
You said it was very affordable. Like, what do you expect the cost to be? you have wires running around the house, right? So you got sensors, you got wires going to the central location, or is it wireless?
No.
What's the communication aspect of this?
The circuitry will be inside a container, so the battery management, the sensing circuitry, and the MSP 430 will all be within its own case. And the actual rope, which is the sensor, will be connected via a port to the box. So there won't be any like wires exposed with our system. And then this box will use the Wi-Fi to connect, so it'll be wireless.
Okay, so you can put these boxes that are all on the house.
Exactly.
There is one question. So when you say highly sensitive, what do you mean by sensitivity? Like you mentioned a number 1.5 millimeter, you know? So is it the amount you're measuring here? What about the density, pressure, and other things?
We just like in a